Hello and welcome. This is Professor Thayer here with you today to talk about flow control. So let's go ahead and get started. While I'm sharing my screen with you here, just a quick review from last time. We have been talking about variables and variable assignment. And most recently, we have talked about how to set up functions and use those functions. And we've talked about how functions can divert flow control. What we're going to talk about is how you can use if and while statements in order to change your flow control. As those statements may suggest, they're going to depend on if something happens or while some condition is true. And that's how we will be working to change the order in which statements are executed. So taking a look ahead just before we delve in, this is our course calendar. Now I am of course recording this in advance, so I'm going to presume that everything's going to stay as planned and that we're going to be continuing the semester as expected. One thing we can expect not to change is I do my absolute best never to change exam dates, just because I know that you need to plan around those. And so I do try to keep those as fixed as possible. But just to take a look at where we're going to be at this point, we are on flow control, right? And so that means in 2 weeks out, we'll have a review. You'll also be doing the Turtle World exercises. This hopefully will be a sort of a fun little thing to do. This is what we would normally do for our lab on the day of the exam. So usually we'd have the exam this day, but we moved it here, so we'll have it as the same day as the other section, which also gives us a review day. But that means we have to do Turtle World because many will want to use Turtle World for the interface for projects. So you'll be introduced to that on this day. And so we need to just pay attention to the upcoming exam. The other thing is the project proposal worksheets will be due. So these will be the week after we have our exam. So I'll be zooming in with you to chat with your ideas for your projects. So you should be picking up your worksheet, filling those out, and sharing your ideas for your projects with me. Okay, so Thursday, October 8th is the date for our exam. It'll be 8:00 a.m. online, so if you have an issue with that time, please do let me know. This is irregardless of when you take your lab, so there would obviously be no lab this day. That's what that is. The other thing I'll call to your attention is that if you do have an academic accommodation letter, do please make sure you're giving that to me. I mean, ideally you should get those in at the very beginning of the semester, but if you haven't already done that, please just let us know. All right, so bird's eye view of what we're going to talk about today. We're going to begin with a few useful tidbits. We'll do the user input function and augmented assignment as useful tools to put in your toolbox, because we're going to need those for doing if statements, since we need to somehow get different inputs, right? So if we hard coded in, we're not going to be able to have variation, but we're going to have if statements. So we're going to ask people for some input, and that's what we'll be doing with the input function. And augmented assignment is our way to shorthandedly cycle through things. Then we'll get into the meat of our talk today. So we'll be talking about the if statements. In here I have in parentheses the chapter references for your book, and just because it is a little bit spread out, the book does cover it in a bit of a different order, so I did put these here for you just for some quick reference. And we'll also be doing the while loop, so we'll take a look at some statements with those, and then also how we can do accumulators and so forth with these. This is like, we may collect some things, and we'll be seeing a lot more of these when we get to the string processing next week. We'll also talk about the for loops. So that's another additional kind of flow control. So while and for loops are having a lot of things in common, but they are a slightly different setup, but the same idea of looping over something in order to process it and get some outcome. So that's what we have in store for us today. So are a few useful tidbits. So remember that we have the input. So we're going to use the input function in order to obtain user input as a string. So whatever the user types, it will be in the type of the Python type of string. In parentheses and in quotes, you're going to specify the prompt to display to the user so they'll know what they need to type. Like, so if the program stops running and you don't have a prompt there, the user isn't necessarily going to know that you want them to type something. So that's why we have to have the prompt with the input so that it will know to display that, and then the user can type something. So the program pauses to wait for the user to type the input on the terminal. So they're going to type it on their keyboard and it will go through, like, so it's going to display on the terminal, they type it in the keyboard, and then the input can then return whatever is typed from the keyboard to the program, which we can then capture in a variable and use that information. We can set a variable equal to the output of the input function to capture the user's answer. So this is typically how we set it up. We have a variable equals input and then some prompt text. So here we have an example of what this might look like. Today equals input, what day of the week is it? So here's the prompt, what day of the week is it? And that the user will type something, and whatever they type will be sent into today. And so today we'll get a variable assignment to that value, and then we can print that back out. So it is now available for use by the program via this print statement and being stored in the today variable. And so here is an example of what that might actually look like. So somebody typed Tuesday, and then it replies, you said today is Tuesday. Now, if you're going to get numerical input, there is a slight problem, and that is because I mentioned that the input type is always string. So if we, in fact, get the user input in the string type, and then we need to convert it to a number, we're going to need to do something. So this is why we learned the type functions. So we can use that information in order to fix the input type. So here's an example. X equals input, please enter an integer. So there's somebody types something, right? So they type 3. Okay. Now, if we ask Python, what do you think the value of X is? You see that it reports back 3, but it is in the type of string because it's got the quotes on it. And if we ask Python, what is the type of X? That's string. So if we want to make it be an integer, this is what we're going to need to do. We can put the int function to change the type of what is input by the user. Okay, so here we have composition. So now we have the output of input being sent to the int function, which is what is assigned to X. So we say, please enter an integer, and they type 3. Python, what is the type of X? Class int. All right, so great. And suppose you wanted to make it be a float. What do you suppose you would do? The next thing we want to think about is augmented assignment. This is very useful, and it is shorthand. It is, in fact, not actually necessary, but computer scientists are kind of lazy people, and they don't like to type a lot. So they come up with a lot of things to do for shorthand. So here's shorthand for common patterns of incrementing, decrementing, multiplying, and dividing variables. And so as we're learning how to do looping today, we will have a situation where we may need to have some variables that increment by 1 every time. Now recall that this kind of a notation, x equals x plus 1, is going to use the current value of x here and add that to 1 and then assign that new value to x. This is not the algebraic expression x equals x plus 1 and solve for x, okay? So it's important that you recall that distinction. So what this means is you have some current value of x. So imagine you have some kind of looping and you start off with x equals 0. And so then you come here, the new value of x equals 0 plus 1. So now it will be equal to 1 and 1 gets assigned to x. That's the kind of a thing. So it will always increment by 1 each time you go through the loop. And so we can do the shorthand for that is x plus equals 1. Similarly, we can also decrement, we can also multiply, and it doesn't necessarily have to be by 1. You can use whatever number, right? You could increment by 3, for example, and also division. So this is useful to know what it means. You may see it in some code, and you may wish to use it. So then, getting into if statements, this is conditional execution. It is depending on whether or not something happens. If. When something is to be done contingent upon some condition, then we're going to have an if statement. This is going to use the Boolean type to decide. Use an if statement to express this kind of information. A branch guard is what determines whether it will run or not. If the Boolean evaluates to true, the branch will run. Otherwise, it will not run. So let's just take a look at some syntax and an example. So here we have if, and now we're going to have some kind of a Boolean expression and a colon. So this is the syntax. You have to include the colon. Now you notice that this is indented, and again, the indentation is part of the syntax here, so it's important that you do that. And then you can have a variety of statements inside of this if block. This is called the branch, which is indented, and this will be executed if this if statement evaluates to true. So here is an example. Suppose you want to get user input and coerce it to a float. Okay, x equals float of input. Please enter a number. Now what we're going to do is we're going to set up a conditional statement for execution. So if x, the number that they entered, is less than 0, print x is negative, and then x squared is equal to x times x. And then we're going to print, and the square is positive, x squared is, and then it will tell the answer. Okay, so you understand that this will only execute if this condition is in fact actually true, that a negative number was entered. If the positive number is entered, or if 0 is entered, then this will evaluate to false, and the expression will be false, and the branch will not execute. So none of those things will happen. So just a quick refresher on the Boolean expressions. The value of a Boolean expression is either true or false. 5 equals 5 is a true statement, and 4 equals 5 is a false statement. So true and false have type bool, and these were the relational operators that we used in order to do the evaluation. So the condition of an if statement is going to be expressed as a Boolean expression. All right, so let's take a moment to practice with the Boolean. So use a Boolean expression to write a condition. So here is some expression written in just plain English. If today is Tuesday, then there's a Comp 112 lecture. So what would the corresponding code look like? So here is a sample output that we would like to get from writing this. And here are the relational operators. So if you want to give yourself a real challenge, you could even put it in the function. All right, go ahead and pause, and we will be back with you momentarily. All right, welcome back. So here is an example of how we could write a conditional statement. So today equals, and this is the string of Tuesday. So if today is equal to Tuesday, right? So this is going to evaluate whether or not this is true. Then it will print it's your lucky day. You have a 112 lecture today, yay. Okay, so in this case, this does in fact evaluate true. And unfortunately, if it's a Thursday, it's not your lucky day to have a lecture, but it is your lucky day to have a lab. But here we're going to check if these expressions are equal, in which they're not. And so when we execute this, we see that nothing gets printed out, so that must have evaluated to false. The body of a conditional may have one or more statements. There is no maximum number. Be sure to indent all the statements belonging to the conditional. If you don't have any information to put there explicitly, you can use pass as a placeholder until you have a statement to put there. So oftentimes we're going to use the pass if we're working on developing the code, but we just haven't decided or we haven't gotten to it yet. This is also a common way when I'm writing a problem for you to solve and I want to give you some starter code. I can do that and put pass there, indicating to you this is where you need to do the work. So here is an example. This is a function called day, and today equals input. What day is today? And some suggested answers are provided. So if today equals Tuesday, print it's your lucky day, Comp 112 lecture, yay. If today is not equal to Tuesday, well, we haven't decided what to do yet, so we're going to put past. Maybe we could have some other options of readings based on the day of the week. So here are some sample executions of this block of code. So if the person indicated that the day today is Tuesday, we get this cute message out. And however, if it's Thursday, you see that this if statement is going to execute. And so pass is here, so nothing happens. So there's no message printed. Alternative execution. So we can do if-else statements in order to have a look at these. So this is a sample flow diagram to show the way that the execution happens. So here we have a condition, and either the true branch or the false branch can execute, right? So we have, if it's true, then the if code inside that branch will execute. And by putting else here, we could have different code that would execute under this situation. No matter which way it goes through, both of them end up back at the same flow control point, and the program continues from there. So when something has to be done contingent upon some condition, and if the contingency is not met, do something else. Again, we're going to use the Boolean type to decide, and an else clause will be used to form the if-else statement. Else must be associated with an if block. You can't just have else by itself. A branch guard determines whether it will run. If the Boolean evaluates to true, the branch associated with the true statement will run. That's whatever is over here. And otherwise, the branch with the else clause will run. Note that exactly only one branch is run. You can't run both because it can't be both true and false. So here's an example of the alternative execution syntax. Again, we have the if statement, and what's new here is the else. So the if statement has the branch guard, which is the Boolean expression, but notice that else does not take any branch guard per se. There's no Boolean expression associated with the else. That's because this one is deciding, and there's only two choices. Either it's true or it's false. So here's the true branch, and here's the false branch. The true branch is associated with whether the Boolean expression is true. So when it is true, the true branch executes. When the Boolean expression is false, the false branch executes. So let's take a look at an alternate execution example. So definition, alternate execution. This is my function. So there's my signature, x equals integer input. Please enter an integer. If x is less than 0, it will print x is negative, and it will carry out this calculation to compute the square and also give some output on the screen. However, what I've changed in this is I've also added else. So we could also have else, and it will print out x is non-negative. So now we have an option for either branch. So here's an example of its execution. Please enter an integer, and the person enters -2. So it reports x is negative and the square is positive, x squared is 4. And this is because it's going through this branch one line at a time. Notice that this statement never executes, and we don't get that output because first of all, it's not true. And second of all, the else screened it out. So this, in fact, is never even run. So then, here is some alternative execution. Suppose you want to have a different outcome based on whether a number is odd or even. Using what you've learned so far, chat with your neighbor to come up with a Boolean expression to determine if a number is odd or even, then incorporate it into an if statement to check whether a number is even. Put your if block into a function odd or even that returns true if the number is even. All right, since we are in the online format, you can go ahead and use the chat function to chat with your classmates if you wish to do so, if you have an idea that you'd like to share. So if you're doing this remotely, you can just think about this yourself and see if you can figure out how we could check if a number is odd or even. All right, welcome back. So I'd like to recall to your memory the modulus, the percent operator, which we saw several lectures back. And I suggested that we may use the percent operator to determine whether something is divisible by 2 or not. And so basically, this is what we're asking you to do in this very question, to decide if something is odd or even. So if a number is even, then it's evenly divisible by 2, and it follows that if the number is even, then the remainder when divided by 2 is 0. So we can use this information to write an if-else statement. So here is an example of a solution to this problem given in the format of a function. So oftentimes at this point, students ask me, oh, do I have to put it in a function? I haven't specifically told you you need to do a function. But generally speaking, we really want to be moving towards using functions. So you should definitely be challenging yourself to answer your questions using functions. So here we have our signature on here. The input is an integer and the output is going to be a Boolean, and a brief summary of what the function is going to do. So remainder is equal to the number %2. So whether or not the number has a remainder of 0 or 1, which would be the choices, provided that it's an integer. Okay, so if the remainder is equal to 0, then that means that it must have been divisible by 2. So we'll return true. Otherwise, we'll execute the else branch, and this will return false. Note that this function is an example where we have multiple return statements in the same function. This is because the function is terminating at either of 2 different places here. So if we take this and execute it, we will get the sample output that's shown over here. Yeah, this part is out in main, just doing the function call based on what the user types. So please enter an integer, and I type 4, and then it returns true, which gets printed in this statement right here. And here is another example using the integer 3, which then makes the else block execute, and false is returned and then printed down in this statement right here. So why stop at just having if and else? Suppose you wanted to have a more complicated scheme and how the information is displayed. So I like to think of chain conditionals as being kind of like a multiple choice. Now, the analogy doesn't work completely, but it gives a pretty good idea. So the idea is that only a specific branch is going to be executed. So when something is to be done, contingent upon some condition, and if the contingency is not met, check if other contingencies are in fact met. So again, we're going to use the Boolean type to decide. What we're going to do is add multiple if clauses to form multiple branches. Each of those if statements will take a conditional statement with it, and then we will evaluate them from top to bottom to see which one is going to be true first. So a branch guard determines whether it will run. The first Boolean that evaluates to true will have the branch associated with it run. Otherwise, the next condition is going to be evaluated, and evaluation will occur in order from top to bottom. At most, only one branch is run, and this is true even if more than one branch in fact evaluate to true, and that's because the first branch that evaluates to true is the one which is executed. So it's important to understand that. If multiple guards are true, the first is the one that's executed. If no guards are true, then none of the branches are executed. So this is an example of what this will look like. This is chained, and you see that we have if-elif, elif, and there's no limit on the number of elifs that you could have. Each one of these is going to have a branch guard associated with it, which will be expressed as a Boolean expression. Each of these will also have a branch associated with it. So with our first if statement, we'll have our first branch, and all of the statements in branch 1 will be executed if this is the first one, which is correct, and so forth. Here is an example. So here we have a snippet of code where there's no chaining involved. So if x is greater than 3, print x is greater than 3. If x is greater than 2, print that, and if x is greater than 1, print x is greater than 1. And so then we're going to look at the chained example. If x is greater than 3, if x is if x is greater than 2, if x is greater than 1. So let me just point out that we could choose x such that all of these statements are true. So for example, I could select x equals 5, and you see that all of these statements would be true. And also all of these branch guards also are true. And so my question is, what will the outputs be for x equals 5? How will they differ? So in fact, these will actually have different outputs. So the important thing to realize here is that in this case, because each of these is if statements, all of them are true, so all of these print statements will execute. However, in this case over here, because it's chained, only one possibility can be executed. The first one, which is correct, is x is greater than 3, which will print x is greater than 3. A branch is executed, and therefore there will not be any more branches in this if statement to be executed. So we will only see x is greater than 3, although x is greater than 2 and x is greater than 1 are also true statements. There is also the possibility of multiple alternatives. So when something is to be done contingent upon some condition, and if the contingency is not met, check if other contingencies are met. Again, we will use the Boolean type to decide. We'll use multiple if clauses to form multiple branches, just as we have done in the chain case. We're going to add an else clause at the bottom to catch whatever does not meet the prior conditions. So this is similar to the if-else setup. And so basically what this entails is just having more choices for elifs. Execution operates similar to the examples shown prior. The first branch evaluating to true will execute, and no other branches will execute. However, adding on this other option is sort of like having a none of the above option in multiple choice. Here's an example of what the syntax looks like. Here we have an if statement, elif, and now we have an else statement down here. So else, notice, does not take a branch guard as we've seen before, but each of the if and elif statements do take a branch guard. With each of these is associated its branch, and the first one, which is true, will execute, and if none of these within the if and elif are true, then execution and else will occur. Notice that if we have chain conditionals, all branches could be false and none of them would execute. However, because we have else here, something is guaranteed to execute. So if one of the elifs or if is true, that's the one that will execute. If none of those are true, else will execute. So there would not be a possibility that no branches would execute, whereas with the chain conditionals, at most one branch will be executed, but it could include 0 things get executed. So here is an example of what this would look like. If x is greater than 3, right? If x is greater than 2, if it's greater than 1, else print none of the above apply. So it's sort of like this catch-all kind of situation where you want to have some kind of a default. That brings us to nested conditionals. So I've taken these nested blocks to help you visualize what we might mean by nested conditionals. So sometimes more than one condition needs to be met in order to arrive at the final answer. So more calculation may be required after one decision, but before another decision. So we're going to use conditionals as part of the body of another conditional. A nested if statement becomes one of the conditional statements of another if statement. That is, the new if statement can be indented inside as part of the branch of another if statement that's on the outside, and so they can be wrapped into each other. So the beginning of each if block must begin with if and not elif. There is no limit on the depth of nesting. So let's just take a look at what this actually means. So it's like first you ask one question and then there's a second question, okay? And we can have nesting in any or just a single one. There's all different combinations of where the nesting could occur. This is nested because this if block is part of the body of this outer if block. Notice that the conditions are going to be set up and using the very similar syntax. It's just that because this is indented here, then these ones will be indented further. And this is what a nested conditional will look like. So we can exemplify this by looking at classifying geometric shapes. So let's imagine that there are only 4 geometric shapes in the world. And of course, there are more than that, but just stick with me for this analogy, if you will. So in order to sort them into the different shapes, what we might want to do is we might want to ask some questions. And the next set of questions that we ask will depend on the first question that we ask. So we might ask, does the shape have a circular face? So if the answer is no, it's definitely not the cone or the cylinder, but we don't know which one it is, right? And so this is why we have these branch points here, and we could have some if blocks to sort the next level. So if we say, yes, it has a circular face, we need to ask another set of questions to differentiate between the cone and the cylinder. Does the shape have an apex? If the answer is yes, we know it's the cone, and if the answer is no, we know it's the cylinder. And similarly, we can follow through this branch of the diagram to discern between the cube and the triangular prism. So this pictorially nicely illustrates how the nested if blocks can work. So what your task is to do right now is to write a function called classify shape that contains nested if statements to classify the 4 geometric solids as suggested by this pictorial diagram. Prompt the user using the input with yes or no, and then return a string containing the name of a solid or undetermined if the input was invalid. So why don't you go ahead and pause this video for a moment and try your hand at writing that function. So here is my solution to how to do the nested, the nesting. There may be more than one way that you could have set this up, so this is only just one way that it could be done. So here we have a function. Notice that I've included my signature and my description at the top. And so I have this variable called yes or no to capture the output of the input. Does the shape have a circular face, yes or no, right? So we're prompting the user to type y or n, and we get that and we store it in this variable here. And now what we're going to do is now we're going to have a branch point. If y or n is equal to y for yes, then it should ask the second question, does the shape have an apex? Yes or no, and then depending on the answer from those questions, we're having some evaluations. We can return cone or cylinder. Otherwise, we could see that this is catching what would happen if somebody accidentally typed something besides y or n, and it's going to return undetermined. Another possibility is that they typed n for no in this particular situation. And so then we're going to ask the question about the number of vertices to figure out whether it's going to be the cube or the triangular prism. We also have these catch-all statements here. This is not a valid y or n answer, it's undetermined. And this is also the else for this outer question here about if they type something that is invalid. And here we've just checked the code to verify that it in fact is working as expected. So I would definitely challenge you to get in the habit of checking your work to make sure it in fact is doing what you expect it to do. All right, so that brings us to the while loops. Repeated execution is what we use while loops for. If statements are going to execute a block of code with 1 or 0 times. This depends if the guard is satisfied, and if multiple guards are true, the first will be executed and the others will not be. A while statement is used for a slightly different purpose. It's used when you have a statement executed a code block any number of times as long as the guard is satisfied. So you want to continue doing it until something changes. Oftentimes this is needed when we do not necessarily know how many specific times or what specific criteria needs to be met. So we may need to do it multiple times until some situation occurs. If the guard is not satisfied, the associated block will not execute. It's possible that this could be 0 times. It may execute an infinite number of times. Now that is usually not done on purpose, and this is called the infinite loop. and this means that the guard is never satisfied. This is undesirable and you should not do this on purpose. However, in the course of writing your code, even the best of us occasionally writes a while loop that does not stop executing. And so what we can do is we can use Control-C or OpenAppleC to exit this, and then life will continue, and we know we need to edit the while loop to make sure that the condition is being met. Usually the problem is there is a mistake in the branch guard, or that there is a variable that needs to get updated that got missed. So this is what the syntax looks like. We would have the Python keyword while, and then again, we're going to have a Boolean expression as the guard, followed by the colon, just like we have in the if statement, just we have the different keyword. Then we would have a block of statements that go inside of this. In repeated execution, we have while loops that are going to have multiple steps through it. So let's just take a look at how this is actually done. So first of all, the guard is going to be evaluated. That is step one. If the value of the guard is false, then the body is skipped. And then that's the end, right? So that's what this is representing here. So we could have while, and we could have that this is false, and then it will just be over. Two, if the value of the guard is false, three, if the value of the guard is true, then the body is executed. So in the event that that happens, we would continue to evaluate the statements that are inside of the body. So after the last statement of the body, control returns to the guard and the process is repeated. So you see that if we go down here, and then what's going to happen is we return back to the top when we reach the bottom of the loop. And now we're going to check, did the while expression's Boolean change to false? So it's going to keep continuing and then going through whatever steps are outlined here, and then return to the top and do it again over and over again until the Boolean expression evaluates to false. So how would it ever change? Well, the idea here is there's probably a variable inside this expression that's getting changed as you're going through the loop. And then we're asking the question, when does it become positive, or when does it, reach some particular criterion? So this brings us to the idea of accumulators. And this is, again, a little bit of an aside, but this is a critical piece of information that you need to have as we think about doing while loops. So an accumulator is not any kind of a special variable. It's just special in the way that it's used. It's a variable that's used to collect information throughout the code execution, such as a loop. You can accumulate information over the course of multiple iterations, such as in a loop. This can take the form of augmented assignment. You must initialize an accumulator before you use it, because again, you cannot reference a variable that does not have a value. So initialization takes care of that problem. An example of an accumulator is a running total. We will see other examples in other loop contexts later in the course. A number of them we'll see next week in string processing. So here's an example using an accumulator. So here we have a function called runSum, and we have our accumulator being initialized right here. Now we have this statement here, while true. So now this branch guard will always evaluate to true. And so we have x equals input, enter a number to sum, and then done to exit. So if x is equal to the value done, it will exit the loop. And this break, I know we haven't talked about break yet, but this break is what will just stop the execution of the loop. Otherwise, if it's not done, then we need to add the current value on. So you see that this is basically like a checkout at the supermarket is going to keep adding the values until you say you put all your groceries through. Then it will return the accumulator. So you see that the accumulator is taking the running sum here. So when we return that accumulator, then that is going to give the value of the total, and that will get returned back to the caller. Here's a function call, and this is just going to print the running total. So you can also have an accumulator loop This is an example using a factorial. So just to recall, in case your math is a little bit rusty, a factorial is expressed using the exclamation point, and you simply just subtract 1 from the number before and then multiply it. So for example, 4 factorial is 4 times 3 times 2 times 1. So it goes down to 0. And so so basically it's going to stop at 1. So when you get to there, it will return the answer. So we could program this in by using a loop. So here is what we're going to do. Our accumulator is going to start at 1, and so while n is greater than 0, the accumulator times equals n, right? So this is augmented assignment. So this is going to be updated. Your accumulator is going to be the running product. So, and then we're going to decrement n by 1 to match this pattern over here. And then we'll return the accumulator. So when x equals 3, we can compute the factorial. So the factorial of x is, and here we're calling the function, okay? So here we're going to call the factorial function and send up the value of x, which is 3. And that's going to return that back to print. And here is our answer. It's going to be 6. Repeated execution can be terminated with break. So we actually saw that sneak into some of the code I've shown you already, but this is formally how this is going to work. So sometimes the condition to break the loop occurs at some point during the execution of the loop. Break provides a means of ending the loop, and often it is inside an if statement, or it could also be inside a while statement, but if statement is the most common. So you have while some expression, first block, statement, blah, blah, blah. If some condition is met, the first conditional statement. So we may execute something and then we could choose to break when this condition is met. Here's an example using break. So we have this while true setup here. So this in and of itself would continue indefinitely. This would be a non-terminating loop or an infinite loop. So we have enter a number to sum and done to exit. So here the person is entering some information, and if they type done explicitly, then it will print the message exiting loop, and it will stop doing the calculation in this block. Otherwise, there will be another piece of information added on, and so the accumulator will continue to accumulate. So what ends up happening is when the user types done, then this block will terminate the execution of the if block, and return will occur, and that's how this particular piece of code is going to work. We also have for loops. So in for loops, we can typically use these with range. And we're going to use these with the preview of strings, because this is oftentimes what we want to do. So for loops with range. So what we're going to do is if we need to loop over some particular set, this can be particularly helpful. So suppose we specify at the start, stop, and step size over which the range should operate. So we will go up to but not include the stop index. If the step is not specified, a step size of 1 is going to be assumed. So this is what our syntax looks like. For some variable in range, and then we give the start, stop, and step information. Again, we have a colon and a body. So here is a for loops within a range. So for I in range 0, 10, 2, print I. So what this says is to use the range of numbers beginning at 0 and going up to 10 and using a step size of 2. So here is it going to print that value of I. So you see that it's going to begin at 0 and then it will increment by 2 because we set our step size as 2. So we have 0, 2, 4, 6, and 8 running here that are getting printed by this line right here. We can also loop over strings. So we'll talk much more about this, but I just want to put this thought into your head right now, so you'll be mulling this over this week in preparation for next week. We could have for a variable in a string, and then what would happen is our string would be processed one character at a time. So a very simple example of what this would look like is a for loop where x is equal to ABC, D, E, F, G, right? And so what we're doing here now is we're going to use the for loop to loop over this string. So it will take each position in turn and have that be the position of focus. So we have for I in X, print I. And you see what will happen here is that it will loop over this string, and the variable I will be set to each of the positions in the string X. So we'll just basically get all of our letters back in order, because it will report on each of them as it is assigned to the variable I. All right, well, I hope that was a useful introduction for you to flow control. So we've talked about a number of things today and introduced a number of new concepts that should be quite helpful in writing your code. So a few useful tidbits. We talked about user input and augmented assignment. We also have if statements and their variants. So in if statements, we have execution with plain if statements. We have the if-else variety. We've also talked about the chain conditionals, where you have if-elif, in which at least one, at most one will execute. And we also talked about nested conditionals, where we would have a condition statement inside of another conditional. We've also talked about the while loops. So we talked about the basic while loop statements and the accumulator and how to stop execution with break. Finally, we talked about the for loops. We talked then about these, that they have the capabilities to traverse strings, and we use them with range. All right, so great job. It's wonderful to see that you're all doing so well with the class material. We do want to keep in mind that we have the exam on the horizon. You should be reporting to your lab sections as registered. You have a homework to be working on. Study for the exam. I would recommend to study often and early. Lecture notes, lab exercises, homework exercises, reading note cards, and practice exam are all great things to be reviewing in preparation for your test. You should also be working on your project proposal worksheet, so this will be due soon. And in this, you need to indicate the topic of your project and the basic ideas you have for how you're going to work it out. Don't forget about the TA help sessions and the office hours. This is where we're available for you in order to help answer your questions. All right, well, thank you very much for joining us today. I hope you have liked the lecture and that this is helpful for you to learn how to program. We will see you next time to talk about strings.